welcome back. Today we will be talking about the rational expressions, and before we understand rational expressions, let's talk about few vocabulary that will help us understand the understanding of rational expression. So expression is nothing but the incomplete sentence. What do you mean by incomplete sentence? That means there is no equal to sign. We are just writing the statement 2x plus 3, the two terms connected with addition or subtraction. Equation, on the other hand, these are complete sentences, and it is how two expressions can be compared with each other. So they are just the complete sentences. So I can rewrite the same example in different way, and I can say that 2x plus 3 is equal to 7. So that is a comparison between expression and equation. Expression is just an incomplete sentence. Equation is a complete sentence with the equal to sign. Function, on the other hand, is a mathematical. It is a mathematical relationship between input and outputs, right? So x is your input and y is your output if you are talking about with respect to algebra. I can write, you can write it as a function format, and you can say f of x is nothing but y, right? F of x, that means a function of x is equal to 2x plus 3. That means y is dependent on the value of x. Inequalities, on the other hand, they are an ordered relationship between expressions. So, for example, we are saying 2x plus 3 is less than 3x, right? So inequality sign is there, less than, equal to, or less than, equal to, or greater than, or equal to. That is the basic idea. Now, with this understanding, let's understand what is a rational expression. Rational, in itself, it is a term that can be written in the quotient form. That means in terms of a fraction. So rational expressions, they have a variable in the denominator. So whenever we have a variable in the denominator, those are called rational expression. So the easiest example of rational expression is 1 over x. X is in the denominator, right? So they are written in the form of function of px and divided by qx. So these are nothing but quotient, right? Written on the quotient provided the variable is in the denominator. Now, based on that, let's talk about the domain of the rational function. Remember, domain is concerned with the x-axis and the range is concerned with the y-axis. So domain of any polynomial is the set of all real numbers unless the domain is restricted. Now, at what point we are talking about the domain is restricted? We are talking about where the denominator is equal to 0. That means if you put the rational expression, denominator of rational expression equal to 0, what values of x are 0, or for the even roots. For example, for the even roots, if we take the radical of x minus 4, so what are my restrictions here? So the restriction is we cannot have x can be all real numbers, but except x cannot be equal to 4, because it cannot be it cannot be less than or equal to 4, because if the value of x is suppose -3, so it will become -3 and -4, which is -7, and we cannot take the square root of -7, because the negative value of x for any square root will create imaginary numbers. That is why for the even roots we need to be a little bit more careful, because negative numbers, they are not real numbers, they are in the category of imaginary numbers. Now and the first condition was that the all real numbers except that makes the denominator equal to 0. So keeping these things in mind, let's try to write down what can be the rule for domain of the rational expression, and then we will take a few examples. So let's write down the rule. So the rule can be division by 0 is not allowed, because when a denominator is 0, it becomes undefined. So 0 is under, it implies undefined. That is the ordinary rule, and then we need to keep in mind those are the restrictions for the domain when we are talking about rational expression. So 1 over x, all real numbers except I cannot have x as 0. So I can write in terms of union symbol. We can say negative infinity to 0, union 0 to infinity, because 0 is not included. We cannot have x as 0. The another example, x plus 5, all real number, but x cannot be negative 5. Anything on the right or on the left of negative 5 will work. So this is how I can write my interval notation. Remember, infinity and negative infinity, they are always open interval, and negative 5 is also open interval because negative 5 is not included. Now in this case, all real numbers except 3. So I can write my interval notation again, the same thing. Now for this case, we have x squared minus 1. So we have to do little work here. So let's solve it. X squared minus 1. Can I rewrite x squared minus 1 somehow? I know it cannot be equal to 0. I can rewrite it as x plus 1 and x minus 1. Sum and the difference of the same term, right? So we are getting two things. X cannot be equal to 1 and x cannot be equal to negative 1. So it broadens our interval. Right, that means broadens in the of the interval. That means we have to write series of interval to write all the restrictions. So we cannot have x is equal to 1 and x cannot also cannot be equal to negative 1. Union negative 1 to 1, and then union again 1 to infinity. And remember, all the signs, they are open intervals because they are not included. Okay, now simplifying the rational expressions. So when we are talking about rational expressions, as I said earlier, we are talking in terms of the fractions. So the same rule for solving the fractions will apply here. You just have to, you can do everything with the rational expressions that you can do with the fractions. Excuse me. So for first example, can I factor out the denominator? It's the sum and difference of the same term. Same binomial, so x plus 1, x minus 1. If you see the similarity, I can cross off x minus 1 from the numerator and the denominator. Right? So the final term that is left is 1 over x plus 1. That will help us define the domain. So domain cannot be equal to negative 1. Now you might consider what will happen, the term that is the binomial that we have just cancelled out. Do this drill. Try to graph this on Desmos and see what happens at x is equal to 1, because what we cancelled out is x minus 1, right? So x minus 1 is equal to 0, that means x is 1. How the graph behaves at x is equal to 1. Do this drill and you will figure it out what will happen, because we will learn about these things more in detail as we will progress ahead in the course. So can we write the domain as x is not equal to 1 and x is not equal to negative 1? Give it a try and let me know in the comment box about your opinion. Let's take another example. Now in the another example, we have quadratic divided by a quadratic. And if you remember something, how to factor the quadratic, what we have discussed in the last video, then the things will be a little bit easier. So just a quick factoring of x squared plus 2x plus 1, I know it is a perfect square. So this is nothing but x plus 1 whole squared, or x plus 1 times x plus 1. And I can factor denominator x squared plus 4x plus 3 as x plus 4, x plus 1 and x plus 3. Now the similarity, I can cancel out 1x plus 1. Again, give it a thought. What will happen at x is equal to negative 1? Graph it again. Will it create a hole? Will it be an asymptote? What? At x cannot be equal to negative 1, but why? What is going on in there? So this is not an answerable domain. This is not my answering domain. Will it create a hole? Just try on your own. Graph it. Pause this video and graph it on Desmos, the whole entire function, and see how the function is behaving at x when x is negative 1. Right? So my ultimate answer is x plus 1 divided by x plus 3. So x cannot be equal to negative 3, because if you put the denominator equal to 0, that is my restrictions. Now building on this, let's understand how to add or subtract. Adding and subtracting, the same thing as we know about the fractions. We are looking for making the common denominators. To make the common denominators, we can multiply the first fraction by the denominator of the second fraction and multiply the second fraction by the denominator of the first fraction. Let's try example 1. So I can multiply the first fraction x over x minus 3 by 3x plus 4, numerator and denominator both. 3x plus 4 times x and x minus 3 times 3x plus 4. Now multiply the second fraction by the denominator of the first. So 2 times x minus 3 and 3x plus 4 times x minus 3. Now when you are making the common denominator, don't add the denominators again. We will just take the one common denominator, so only 3x plus 4 and x minus 3. But we will add the numerators together. So if I simplify it, it will be 3x squared plus 4x plus 2x minus 6. We can combine the like terms. 3x squared plus 6x minus 6 over 3x plus 4 times x minus 3, that will be 3x squared minus 5x minus 12. This is your final answer. Now we have another example. 4 divided by 9x plus 1 minus x over x plus 9. We will do the same drill. Multiply the first fraction by the denominator of the second. Denominator of the second is x plus 9. And multiply the second fraction by the denominator of the first. What is the denominator of the first? 9x plus 1. Let's simplify it again. We will write the fraction only one time. I have helped you to set this equation up. Try to solve it on your own. And check your answer. Your answer should be this: negative 3 times 3x squared minus x minus 12. Everything over 9x squared plus 82x plus 9. Try. You have the whole entire setup. You just have to simplify the numerator and simplify the denominator together. Let's quickly do multiplying the rational fractions. For multiplying the rational fractions, factor if you can, if there are any factors. Then cancel common factors from the numerator and denominator, find restrictions, and then simplify. multiplying the rational expressions, multiplying any fractions, they are quite easy. What we have to do? We have to just multiply the numerators together and multiply the denominators together. But here we have the polynomials, so we will simplify it first. We will factor it out first. So let's factor out the first fraction first. So I can factor out 2x squared plus x minus 6 as 2x minus 3 times x plus 2. Now let's simplify the denominator, which is x squared plus 4x minus 5. So if I factor it out, it will be excuse me, x plus 5 times x minus 1. That is simplifying of the first fraction. Let's do the same thing with the second fraction. It will be a little bit lengthy work because you need to factor out all the polynomials. But it's worth it. So if I simplify it, remember it is a cubic, right? So x times x minus 1 times x minus 2, factor cubic. And the second is 4x squared minus 6x. If I factor it out, it will be 2x x minus 3. Now we have the factored form of the original fractions, right? Let's rewrite this question again in terms of the factored form. 2x minus 3 times x plus 2 over x plus 5 times x minus 1 times x minus 1, x minus 2 over 2x minus 3. Now from here I can cancel out a bunch of stuff, and cancelling out is fun. So 2x minus 3 cancelled out from numerator denominator. Then we can cancel out x minus 1 from numerator and denominator. And then we can cancel out one more thing, that is x and x. Let's rewrite. So x plus 2, x plus 5 times x minus 2 over 2. And I can simplify it further, provided we cannot have x cannot be 3/2. Why I wrote 3/2? Or x cannot be equal to 1, or x cannot be equal to 0? Because whatever we have cancelled out, if you put them equal to 0, for example, if I put 2x minus 3 is equal to 0, you will get the x value as 3/2. And because the x value is 3/2 at that point, so I cannot have x as 3/2. If you put x as 3/2, it will make the whole entire denominator as 0. Same thing, we cancelled out x minus 1, that means x cannot be equal to 1, and we cancelled out x as well. So x cannot be as 0, because these numbers will create our fraction as 0, and we don't want denominator to be 0. So my final answer will be x squared minus 4 divided by 2x plus 10, or you can write in the factored form as well. There is also one problem right here. I want you to try this question on your own. If you get the answer, please write it down. We will discuss it. Now the last thing, that is called a complex fraction. When we are talking about complex fractions, we are technically talking about dividing the two rational expressions. So we have a fraction as a numerator and a fraction as a denominator, and we have to simplify it. So there is a technique to simplify it, but let's identify what is a numerator. Numerator is a over b and denominator is c over d. But remember one thing, denominator of a denominator will become a numerator because we have a denominator, right? And if there is another denominator underneath, it will go up and it will become the numerator. So you can rhyme it in your head, denominator of the denominator becomes the numerator. And if you understand this, it will make your life so easy to solve these complex fractions. Then they will not remain complex, they will be easier and they will be fun to do. So let's try the example. We have 3/4 divided by 5/7. Technically, I can write it down with the division sign, and there is also something called KFC that I have discussed in the another video. We are keeping the first fraction, flip the second fraction, and change the sign to multiplication. Now it is just a multiplication. So multiply the numerators together and multiply the denominators together. This is nothing but fraction, denominator of a denominator becomes a numerator, and denominator of a numerator goes down as the denominator. So your answer will be 21/20. Let's try one more. So we have x squared minus 1 over 3x. With the division sign, I can write as x plus 1 over x. Let's apply KFC one more time. So I can simplify it x squared minus 1 as x plus 1, x minus 1 over 3x times, apply KFC. So it will be x over x plus 1. Don't get confused with the multiplication sign. Let's use dot for the multiplication. Now at this point, can I cancel out something? Yes, we can cancel out x plus 1, and we can also cancel out x. So let's write it down first and then we will cancel out x. Now at this point, we can cancel out x. So my leftover answer will be x minus 1 over 3. So this is the gist of how to solve the rational expression, and I hope you learned something out of it. Just keep on practicing. I will see you in the next video. Thank you. Make sure to like and subscribe.